Welcome to today's explainer. We've got a seriously fascinating model to unpack today. You've probably heard the chatter. MiniMax H3 is being hailed everywhere as the literal holy grail of AI video generation. People are calling it a true omnimodal powerhouse. But before we get completely swept up in all that hype, we really need to take a hard look at the reality here. Because as you're about to see, unlocking this incredible tech, it comes with some massive and honestly pretty unusual catches. Okay. Let's dive into this. A recent review by Kingy AI actually hit the nail on the head, summing it up like this. They called it brilliant audio-video generation with a giant local compute and licensing asterisk. And that quote right there perfectly sets up the mystery we're decoding today. So what exactly is behind that giant asterisk, and is dealing with it actually worth your time?
Well, to really get the hype, we have to start with a fundamental question. What if a video model could actually hear? Think about it. Traditionally, making AI video is kind of like shooting an old silent film, right? You generate the visuals first, and then you have to painstakingly stitch in all the sound effects, the dialogue, the music, using totally separate, specialized models later on. But imagine if a single AI model could act like your entire production studio, handling the visuals and the sound all at the exact same time.
And that is exactly what MiniMax H3 does. It generates a video and native 32 kHz stereo sound in a single, unified pass. It's wild. It can pump out up to 15 seconds of perfectly synced video and audio using just one continuous multimodal context, no separate audio model needed, and zero syncing required after the fact. So let's look at Section 1, Omnimodal Video and Sound, and how it's breaking the modality barrier. The secret sauce behind all of this is something MiniMax calls contextual omni-representation. Now, instead of boxing different tasks into specialized silos, this system uses natural language as a bridge. It literally unifies text, image, video, and audio understanding into an open descriptive form. So H3 isn't just blindly looking at a reference image or, just listening to an audio clip. It actually understands the complex relationships between them, using language as a sort of generalizable interpreter. And this brilliantly illustrates just how powerful that is. In a single generation, H3 gives you up to 15 seconds of video running at 24 frames per second, complete with that native 32 kHz stereo audio we mentioned. And get this, you can feed it semantic references from up to 12 mixed files. So we're talking combining images, videos, audio clips, and it supports 11 different languages. It's essentially replacing a whole stack of specialized models with just one incredibly capable system. Moving on to Section 2, let's talk about the real weight of H3. And why calling it 33 billion is actually a bit misleading. So MiniMax pitches the H3 Omni Transformer itself as a 33 billion parameter model. Sounds big, but manageable, right? Well, to actually run it, you need the whole stack. When you add in the massive Qwen3VL text encoder, plus both the visual and audio VAEs, the total stored weight size for just one single task partition hits a staggering 134.13 GB. And remember, that is literally just the storage footprint. That's before we even start talking about runtime memory overhead. Which brings us to Section 3, the hardware reality check, or, as I like to call it, data center computing at home. 384 gigabytes. Yeah, you heard that right. That is the amount of system RAM your computer needs to have if you want to run the official lossless consumer configuration on two RTX 5090 GPUs. Just let that sink in for a second. Because to handle all the layers streaming and offloading required for a file this colossal, you are going to need roughly 384 gigabytes of system RAM. And when we look at the hardware comparisons, wow, the performance gap is agonizing. On a high-end data center setup running 4 H100s, your inference latency is a blazing fast 13.25 seconds. Awesome. But if you step down to a high-end consumer setup using two RTX 5090s, that exact same generation takes roughly 9.3 minutes. So the heavy compute reality here is that to get true, fast local generation, you're basically looking at a six-figure server rack. So why is H3 so incredibly demanding? Well, first off, because it uses a diffusion transformer, it doesn't have the standard memory shortcuts, like a KV cache, that we're used to traditional text models relying on. The dense transformer has to be repeatedly evaluated over tens of thousands of tokens. To put that in perspective, a 15-second clip equals roughly 91,000 target video tokens alone. Plus, this initial open-weight release is missing MiniMax's trained sparse attention. And without that specific optimization, computing these massive long sequences becomes insanely expensive. All right, let's hit Section 4,
The giant licensing asterisk, open weights, closed borders.
So the crucial point we need to talk about is the MiniMax H3 Community License Agreement. It's got some highly unusual legal restrictions. It explicitly excludes the United States, the European Union, the United Kingdom, and South Korea. On top of that, commercial product revenue is capped at $20 million, and any product using it has a mandatory MiniMax H3 UI branding requirement. So just because a model is sitting there ready to download on Hugging Face absolutely does not mean you have permission to deploy it everywhere.
Let's move to Section 5, running H3 locally, and the workarounds for the rest of us. Thankfully, through tools like Comfy UI, the community has actually managed to shrink this behemoth down to a slightly more manageable 42.5 gigabyte package for consumer GPUs. The process looks like this. You download the official pruned INT8 diffusion models, you implement NVFFP4 text encoders to save some crucial space, you heavily offload the VAEs, and finally, you add in a custom Sage Attention node. And what's really interesting here is the impact of that Sage Attention node. By optimizing float 16 and bfloat 16 tensors, it can roughly double your generation speed on local hardware, and it does it with minimal quality loss. Now, it does require some manual installation, and it might skip some layers, but it is for sure a vital tool if you want to make local generation even bearable.
Let's look at Section 6, the final verdict, base model versus the API.
Let's move to and see how this builds up. On the one side, we have the local H3 base. Look, it's an absolutely incredible technical achievement, right? But it caps out at a 768 pixel short edge. It requires staggering amounts of compute, massive RAM, and really careful quantization just to get the thing to load. Then on the other side, we have the fully featured hosted API.
And honestly, the hosted API advantage is just impossible to ignore. Unlike the open weights, the API gives you full 2K resolution through their proprietary H3 Regenerate 2K stage. It also uses their proprietary H3 Context IR prompt system, so it better understands your instructions. And the picker? All of this costs just $1.20 to $1.95 per 15-second generation. It is hands down the cheapest, most sensible place to validate your workflows, and you completely avoid that six-figure hardware bill. I really love this concluding advice from the Kingy AI review. It says, evaluate the hosted API with your own multimodal shots first. Move to local H3 base only when privacy, tuning, or sustained volume is worth the operational cost. That is just incredibly pragmatic advice. And remember, before you go downloading those weights for any sustained volume, you absolutely must ensure you are operating in a permitted territory according to their license. Which leaves us with this final, kind of provocative thought to ponder. H3 is a marvel of multimodal integration, no doubt. But with these staggering hardware costs, missing proprietary stages in the open release, and those closed border licenses, is the era of truly accessible, open-weight frontier video models already over? It's a really complex question, and one we are definitely going to have to keep an eye on. Thanks for joining me on today's Explainer, and keep exploring.